Hi guys, welcome back to my channel. So today I'll be doing an airline data analysis using SQL and Python. So let's check out the business problem. Our company has been providing high quality air transportation service to our clients for several years, ensuring a safe, comfortable and convenient journey for our passengers. We operate a diverse fleet of aircraft ranging from small business jets to medium-sized machines. However, we currently face challenges due to various factors such as stricter environmental regulations, higher flight taxes, increased interest rates, rising fuel prices, and a tight labor market leading to high labor costs. These challenges are putting pressure on the company's profitability, and we are actively seeking solutions to address this issue. In order to tackle this challenge, the company is planning to analyze their database and identify opportunities to increase the occupancy rate, thereby boosting the average profit earned per seat. Okay, so what are the obstacles? Stricter environmental regulations. The airlines industry is facing increased pressure to reduce its carbon footprint, leading to the implementation of more stringent environmental laws. These regulations not only raise operating costs but also restrict the potential for expansion. Higher flight taxes. Governments worldwide are imposing heavier taxes on aircraft as a means to address environmental concerns and generate revenue. This increase in flight taxes has raised the overall cost of flying, subsequently reducing demand. Tight labor market resulting in increased labor costs. The aviation sector is experiencing a scarcity of skilled workers, leading to higher labor costs and an increase in turnover rates. Okay, right, so let's upload our data set. Okay, so it's a SQLite file, and in the meanwhile, let's import our libraries. Since it's a SQLite file, we would need a library to import the database. Now let's connect it to our database. Connecting to database. And the path. Okay, so copy path. Okay, so now let's check how many tables and what tables do we have in this database. Okay, so we have aircrafts data, airports data, boarding passes, bookings, flights, seats, ticket flights, and tickets. Okay. Okay, so let's explore our data now. Data exploration. So I'm checking the first table as of for now. And this query here is select star from aircrafts underscore data. Let's see. Okay, so I believe there is some issue. Let me rectify it. Let me check. Okay, so I believe this is Russian. Okay, so this is English. Okay, so I believe the flight numbers are in multiple languages. The models, the name of the models are in multiple languages. So this is A in English, and this is in RU, this is in Russian. So we need just the English ones. So for model, I'm applying lambda, and JSON loads X English. Alright, so this is good to go now. Okay, so now let's check the airport's data. Okay, let me rerun all of these again. Time run all. I believe it should work now. Okay, yes. Okay, so this has the same problem. English, Russian. So we would remove the other ones except English, just like the previous cell. Okay, so we would do this on the airport name and city. So as both of them contains Russian language. Now let's check it. Okay, so now we have a clear data on this airport name, city. Now uh, let's move to boarding passes. Okay, so we have ticket number, flight ID, boarding number, and seat number. Okay, and after the boarding passes, we have bookings. Okay, so we have book reference, book date, and total amount. Okay, and after that, we have flights. So we have flight ID, flight number, scheduled departure, scheduled arrival, departure airport, arrival airport, status, okay, aircraft code, actual departure, actual arrival. Alright. And then we have seats. Okay, so this is aircraft code, seat number, fare conditions, business, economy. Alright. And after seats, we have ticket flights. Okay. Ticket number, flight ID, fare conditions, and amount. Alright, so after ticket flights, let me check what we have next. Okay, so we have tickets. Okay, so we have ticket number, book reference, and passenger ID. Alright. Alright, let's do some visualizations. So first, let's check the airplane models and the ranges. And this is for labeling the bars. So this loop. is for labeling the bars. Okay, so these are the ranges. So Boeing 777-300 is the highest range, and Cessna 28 Caravan has the lowest range. Alright. And now let's check the planes having more than 100 seats. So here we are running a query where we are selecting the aircraft code. We are counting the number of seats as we have grouped the aircraft code with a condition having number of seats greater than 100. And we're saving it to aircraft underscore seats.csv. Alright, now let's check the aircraft codes versus number of seats. So here at x-axis we have aircraft code, y at number of seats, the data as the data frame we have just saved, and again this is for labeling the bars, this loop. Let's check. Okay, so 773 has highest number of seats, 402. Okay, and 319 has the lowest number of seats. Alright, now let's derive the name of the airplanes using the aircraft codes so that we can know that which planes are these. So aircraft code model for English, and we put the codes here. Okay, let's see what is the error. Execution failed. Okay. Okay, so let's check this error. Okay, so we have used the wrong syntax, I believe. Okay, so let's try this. Alright, so this worked. So I believe I made a syntax mistake. So for extracting, we used model and then $.an. So we have successfully derived the models. So as we saw that 773 has the highest number of seats. So 773 is Boeing 777-300. Alright, so now it's number of tickets booked and total amount earned changed with time. Alright. So this is pd.read underscore SQL query select star from tickets inner join bookings on tickets.book underscore reference is equal to bookings.book underscore reference. Alright. And the book date we'll convert it to date time and the date to dt.date. And then we are grouping by. And now let's run this. Okay, PD is not defined, so let's run all once. Let's see if this is corrected or not. Okay, so the peak went on to this date. This is somewhere around 8th of August 2017, between 15th of August. So it looks like somewhere around 14th of August. Alright. Okay, so let's check why did this peak came. It might help us, in increasing the revenue. Let's run this. Let's see for the bookings now. Okay, so number of tickets booked on each date, same as. Wait a minute. Okay, this is for tickets and this is for bookings. Okay, so it has absolute similar pattern. They're correlated. Okay. Okay, so we didn't find much in this, so let's do one thing. Let's check the fair distribution. Okay, so this is average amount and we have a peak in 319. Okay, 319, and it's a business class. Right, it's a business class. Okay, and 763. They have the highest in the business class, and in economy, the highest is again 319. Okay, and for the comfort, the highest is 773. Alright. Okay, now let's again check the craft's name using the model numbers. Oh, same problem again. Give me a moment. Okay, so now 319 is Airbus. So the Airbus has the highest in the business class and the economy class, and then the highest in business class is 763, which is 0.767. Okay, and the highest in comfort is with 773, which is 0.77730. All right. Now let's check uh, total revenue per year and the average revenue per ticket. Alright, so now let's check the revenue CSV. Okay, so aircraft code, ticket count, total revenue, and average revenue per ticket. Now let's visualize this with total revenue versus the aircraft code. Let's check this. Okay, so this is SU9. SU9 has the highest revenue, and SU9 was, let's check, SU9 was Sukhoi Superjet. Okay. Alright, so now let's check the average occupancy rate per aircraft. All right, the average occupancy rate is the highest of 733. 733 0 points. Oh, sorry. So 773 has the highest occupancy rate. Number of seats 402. Okay. All right. So occupancy rate is directly proportional to the revenue. So we'll calculate how much the total annual turnover would increase by giving all aircraft a 10% higher occupancy rate. Okay, so 773 would go to 0.72. All right. And now let's see how would it affect the turnover, the revenue. Okay, so this would go 5, 6. So previously we saw that SU9 had the highest revenue, and it would turn out to 56259333169. All right. All right, guys. Thank you very much for watching my video.